Hey guys, and welcome back. So this is your asynchronous day. So I'm going to go through the notes that you need to fill out, and then I will go through what your practice is for the day. So the objectives today are that you will be able to identify types of numbers and expand and simplify powers. So you will identify if a number is irrational, rational, natural, whole, and or an integer, and then you'll write exponents in words. So part one is the real number system. So all of the numbers in the number system we'll use in this course are what we call the real numbers. And you might say, Miss Ayers, there's different numbers. Like, how can they not be real? And in Math 2, you'll start looking at what it means to have numbers that are not real. But for the purposes of Math 1, all numbers are real. So the real numbers are all numbers. And that is in Math 1. Math 2, Math 3, Math 4, you start looking at numbers that are not real anymore and why they are and why they exist. So then from real numbers, we branch off to two different types of numbers. The first type is irrational numbers. And these are decimals that never end and have no patterns. If you think about mumbo jumbo numbers, like they're just random decimals that don't have an end, they don't have a pattern, they're just there. And those are what we call the irrational numbers. And so that is with an I. So we represent that with an I. And some examples are pi, and then any square root that is not a perfect square. If you're not sure if a square root is a perfect square, you can just type it in your calculator. And if it comes out to be a decimal, then it is irrational. So it's really just pi and all of your non-perfect square roots. After irrational, there's nothing else on that side of our little branch. So we're going to branch back over to our rational numbers. So rational numbers are just all of our fractions and decimals that end or have a pattern and repeat. And we let those be represented with a Q. And that'd be like 1/3, 0.2, because it ends and it could be written as a fraction, which would be 2/10, which simplifies to 1/5. -2 and 4/5, so it includes your negative decimals and fractions, and then 0.6 repeating. So anything that can be written as a fraction. So if you get a decimal in your calculator, if you hit math, enter on a graphing calculator, you can turn it into a fraction. And that means that it would be rational. The next type of number is a whole number, and they're opposites. So it's your integers. So your integers will be listed with a Z, and that's just all of your whole positive and negative numbers. So no fractions, no decimals, just your whole numbers and including the negatives. Your next type of number is your whole numbers, and that's just all of your natural numbers plus 0. And we let that be W. So it'd be 0, 1, 2, 3, 4, ... Goes on and on forever. Just starts with 0 instead of 1. And then your whole numbers are your natural numbers are just your whole numbers, but they begin with 1, and that's an N. So I like to think of the natural numbers as the numbers you naturally start counting with. When you're a child, you start counting things, right? You start counting at 1. You never start counting at 0. You always start 1, 2, 3, because you're generally counting items. And then when you get into elementary school, you learn about that number 0. And then later in elementary school into middle school, you start looking at the negatives. And late elementary and in middle, you look at the fractions. And so we have all these different numbers because if I draw a number line, I have 0 and I have 1, there's a lot of numbers in between. Like I can put a 0.5 for a 1/2, and then in there I can put a 1/4, and then in there I can put a 3/4. And I can keep breaking this down. And so we need all these different types of numbers because there's an infinite number of numbers that lie between 0 and 1. And these are all of the types of numbers that lie there, well, except for integers. But your irrational and rational make up the in-between between 0 and 1. And so that's why we have all these different types of numbers. It's important to note that a number that falls in the natural number category is also whole and integer and rational. Because if the number is 2, 2 is natural, but then it also falls in my whole number spot. I also wrote it in integers, and I can make 2 a fraction by putting it over 1, which makes it rational. The only time it's not anything else besides itself is if it's at the very top of our list, which would be rational or irrational. Integers, whole, and natural are also all the things above them. That's why they're in this table the way they are, and that's what this little line thing makes. Everything that's rational is rational, but everything below it also builds up. Let's look at these examples. So name all of the sets of numbers to which each number belongs. So if we look at 30, we can come over here and we know that 30 is going to be above 4, so it'll be a natural number. And since it's a natural number, then it also is going to build up. So it's natural, and then it's whole, then it's integer, and then it's rational as well, because I can write that as a fraction. So I'm going to write natural, whole, integer, and then I'm going to write rational. When I look at negative 11, I know that it's not natural because of the negative. I know it's not whole because of the negative. But because it's negative, I know that it is an integer since it's negative with no decimal. And since it's an integer, it also needs to be rational. Looking at 5 and 4/7, it has this fractional piece, which cuts off natural, whole, and integer. But since it does have a fraction, that makes it rational, and that is all. Really, we should have also been writing real for each of these, but we're just going to take that one as is. Number 4, negative square root of 9. So this one we have to think about. So we said if it was an imperfect square root or non-perfect square root, that it would be irrational. So we got to think, is the square root of 9 is it a perfect square or not? And if you think about it, the square root means that something needs to multiply by itself to give that number. So if you type the square root of 9 in your calculator, you're going to get negative 3. So negative square root of 9 is actually equal to negative 3, which is an integer. So that means that this negative square root of 9 is an integer. I always want to put an extra R in integer. Just integer. And since it's integer, it's also rational. When we look at the square root of 27, if you type that in the calculator, you're going to get 5 point something, 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 something. So since it doesn't come out to be a whole number, that means that it is irrational. Now let's look at part 2. The basics of exponents. So we have this diagram here, 2 raised to the 6th power, and we're going to name all of the parts. So the 2 is what we call the base. The 6, that's a little thick, is what we call the exponent. And both of them together, this entire piece, 2 to the 6th, is what we call the power. So we wanted to have a lot of times we call it the exponent, but really the exponent is just that little tiny number up in the air. The entire thing is the power. And what it means is that you're going to take your base and write it out the number of times of the exponent. So the base is what's being multiplied. And the exponent is how many times. So if I want to expand 2 to the 6th, I would come out to be 2 times 2 times 2 times 2 times 2 times 2. So I'd have 6 2s. All right. So we're going to complete this table. If you're filling it out on Google, you're going to want to use Shift 6 to indicate an exponent when you write it over here. So the number the base, the exponent, expanded form, and standard notation. So expanded form is where you write it out the number of times. Standard notation is where you actually do the multiplying. So when we look at this one here, 2 to the third power, our base is 2. Our exponent is 3. So when we write it in expanded form, we're going to write 2 3 times. We're going to multiply 2 times itself 3 times. And then we're going to write it in standard notation. So you do 2 times 2 is 4. And then 4 times 2 is 8. Looking at this one, we have 3 to the second power. So our base is 3. Our exponent is 2. So we're going to write that 3 times itself 2 times. So 3 times 3, which will give us 9. Jumping down to this row, we see that the base is 6 and the exponent is 2. So I'm going to have 6 to the second power. So expanding that out would be 6 times 6, which is 36. And then the row below it, I look and see, they told me what the base is, but even from expanded form, I should have known the base was 8 because I've written 8 multiple times. It's written 3 times, so that's the exponent. So my number is 8 to the third. Then when I want to figure out what it is, I'm going to do 8 times 8, which is 64. 64 times 8, which gives me 512. The rest of this table is going to become your practice. Write the verbal expression for each power. So what you're going to do is write these out in words. So this first one, you're going to write it as you should read it. So you read it as the base to the whatever power. So 12 to the first power. So if you kind of wanted a sentence frame there, you would have the base to the exponent power. So if I look at this one here, I'm going to make this one number 2. This has a negative out front, but the negative is not raised to the 4. So remember, the only thing that gets the exponent is the thing directly to the left of the exponent. Since the negative is not touching the 4 and not in parentheses, that means that the negative doesn't actually get raised. And so when we write that in words, we want to think of, instead of writing negative 2 to the 4th power, we're going to write the opposite of 2 to the 4th power. And that's different from this one below it, number 3, that has the negative in the parentheses. The parentheses means everything in the parentheses is raised to the 4th power. So this one would be written negative 2 to the 4th power. So the exponents are very important in these examples. So make sure that you're paying attention to what is being raised and what is not. The rest of these 3 will also be part of your practice. And this last section just has you writing the expression using exponents. So anytime you see something that is written out multiple times itself, you know that it's an exponent. So since I have 3 negative 5s, then I'm going to write negative 5 to the 3rd power. I want to use parentheses because the negative is repeatedly multiplied. If it was written negative 5 times 5 times 5, then that would be negative 5 cubed, because we only have a negative once. And number 4, it works the same for x's. You just count up how many x's that you have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. So that means our exponent will just be a 12, with a base of x. And if you have multiple variables, you just write the exponent for each variable. So we have 1, 2, 3y, so that's y cubed, 2z, so times z squared, and then 3r's, so that's times r to the third. The rest of these examples will also be part of your practice. Speaking of practice, so your practice for today that should be turned in for credit is going to be the rest of the examples on this piece of paper that you haven't done, as well as this real number system card sort. And the way this sort works is you will take your mouse, hover over a number, it's like -97, we know would be an integer. So you're going to drag it and put it in the integer spot. So you'll drag each of the numbers down below and put it in the correct bin at the top. Do make sure you type your name up there in the red, and then make sure that you turn all of this in on Google Classroom by the end of today. If you have any questions, I will be available via email and until about 4 o'clock. All right, have a great day. See you tomorrow.